Automated continuous build and continuous delivery are must-haves when you're building modern applications on AWS. To achieve this, you've numerous options, including third-party providers like GitHub Actions and Circle CI, and the AWS services CodePipeline and Code Build. This is our topic for today, so you're going to hear about what CodePipeline offers and how to set it up, what are the trade-offs and when to choose one over the other, and when you should look outside AWS to a third-party provider for continuous deployment. We'll also talk about the rise of GitHub Actions and when to choose it and all the features it offers. My name is Owen, I'm joined by Luciano, and this is the AWS Bytes podcast. Okay, Luciano, regardless of the service we're trying to pick for continuous integration, continuous deployment, continuous build, what are we trying to achieve? Maybe we should talk about that first.
Yeah, I think there are a number of use cases when it comes to discussing topics such as CI and CD. And so let's try to come up with a list of the different things that you might want to do with this kind of technology. So first of all, you might want to do something that we can define as automated build. For instance, you have a repository with all your source code. You do things on that repository. I don't know, you open a PR, you merge that PR, or you just push a commit. You might want something to happen as a reaction to that event. And that reaction is probably building your code and doing something with it. I don't know, running tests, making sure that your code is okay and conform to certain standards that you defined. Then another aspect is releasing a specific artifact. So this is maybe something you will do, for instance, when you create a tag on your repository, you can say, I don't know, this is version 1.5. And then at that point, you want to kind of archive that particular version and package it in such a way that it can be easily deployed to a particular environment. Then there is the deploying itself, where it's basically you take one artifact and you all the code inside it. Somehow you deploy that to an environment. That might mean, I don't know, if it's defining containers, probably those containers, the artifact is going to be an image in a registry, and you might want to publish and run a task, for instance, on ECS using that image. Or maybe it's a serverless function, so you might want to deploy that function and run it. Or sometimes it can be even something more complex. It can be, I don't know, an entire CloudFormation stack, and you want to apply all the changes in that stack. So it's really up to you to define the granularity, but the concept is you build, you create an artifact, and you try to deploy that artifact. And there are other things to keep in mind. For instance, most likely we want to be using different environments and different applications. So how do you manage maybe different AWS accounts, one per environment? How do you manage multiple applications running in AWS accounts? We spoke before, should you use multiple accounts for multiple applications, multiple accounts for multiple environments? So you might have a very large matrix of combinations there, and your CI/CD needs to be able to interact with all of those. And then there are other two aspects that I would classify as observability and security. So on one side, you want to know exactly what's going on. So if you're doing a deployment, what are the different steps? And if something goes wrong, at which step did it go wrong? And you should be able to see logs and react to whatever is going wrong. And finally, in terms of security, that's kind of a very broad term, but in general, we want to make sure that our CI/CD doesn't get compromised, doesn't become kind of an attack surface for people to just, what if they can steal credentials, for instance, and then they can impersonate your CI/CD and do all the things that your CI/CD can do. So there needs to be also a certain level of concern around making sure that your CI/CD infrastructure is as secure as possible, because generally that layer has a lot of permissions because it's literally spinning up new infrastructure, changing existing infrastructure, and so on. So yeah, I think that covers more or less what is the need. But speaking of AWS, how do we do all this stuff? Because I know there are so many different services to do all these different things, and I often get confused about which service does what. So should we try to do a recap?
Yeah, in the AWS console, if you go to developer tools, you see 4 or 5 different services. And the main ones there are Code Commit, and that's kind of their alternative to GitHub and Bitbucket and the like. So we're not really going to cover that here, since we're assuming people are using something like Bitbucket or GitHub. We've also got Code Deploy, and this is a specific service for deploying to EC2 or ECS or Lambda. We talked about it a little bit before. You can do blue-green deployments with it. That can be used regardless of whether you used CodePipeline or a third-party service. So let's also park that to one side. The other two main services are Code Build and CodePipeline. So those are really, I guess, what we're going to focus on today. Code Build is like the basic building block, and it compares in a little bit to what Circle CI or Travis or other similar services offer, in that you can declare a YAML file called a build spec, and that allows you to declaratively write all your build steps, and CodeBuild will execute them for you. Because it's an AWS service, you always need to kind of create a resource for that to work. So you also, before that works, you have to create a CodeBuild project and associate it with a source like GitHub or Bitbucket. Then you can pick a container image for your project to run in, and you give it an IAM role to use. You can configure the size of the instance. Well, in all, I think CodeBuild is a pretty good service as a basic build execution environment, but it's, I would say, no frills, right? It doesn't provide a particularly good UI or anything. CodePipeline then is like a continuous deployment or continuous delivery workflow service. So it allows you to chain multiple stages and actions together. So you can use it together with CodeBuild, and it will allow you to orchestrate multiple steps. So in CodePipeline, you have this concept of stages. So each phase of your workflow is called a stage, and each stage can have multiple actions. And actions can be run in parallel or in sequence. And there's lots of different actions you can do. So you've got source actions, and then you've got... so source actions can come from GitHub, can come from S3, ECR, code commit. And then for actually doing stuff based on that source, you can run a code build job. You can even run Jenkins. And there's also lots of third-party providers as well, including lots of providers for running specific tests. So it's well integrated into lots of AWS services, but also third-party services. And it then allows you to deploy with code deploy out to ECS. You can deploy out to S3, Elastic Beanstalk. As well as that, if you really want to do custom stuff, you can invoke Lambda from CodePipeline or a step function. I've spent actually a lot of time creating pipelines based on CodePipeline and CodeBuild, and that might be a little bit of a hint as to where these services fit, because you do end up spending a lot of time. We do have an open source project called Slick Starter, which is like a serverless template project that you can use for exploring lots of different things you need to implement when you are creating a serverless project. One of those is continuous deployment, and in there's a CI/CD folder that has a CDK project that creates CodePipeline and CodeBuild with all of the build phases, integration tests, and multiple stages to multiple environments. It supports cross-account deployment, and that's probably a good example, because to achieve something like that, you do need to spend quite a lot of time. But let's maybe talk about the advantages there first. So with CodePipeline, everything is well integrated on AWS. That's always going to be the advantage of picking the AWS native option. You can also maintain the pipeline code using the same infrastructure as code, be it Terraform or CloudFormation or CDK, as you do for the rest of the application. So you can manage all those changes together, and the way you do it it's fairly consistent, right? Everything is an AWS resource. It also kind of scales well, right? You've got the elasticity of AWS with your code build jobs, and you can get notifications as well. So you get SNS notifications on your code pipeline. You can integrate that to Slack using AWS chatbot. It's obviously quite well integrated into the AWS ecosystem. But having used it quite a lot on multiple projects, I still think there's lots of areas where CodePipeline and CodeBuild could be improved. Right. So the main disadvantages, I'd say, would be, like I said, there's a steep learning curve, right, compared to the alternatives. You kind of have to design and deploy the CodeBuild projects, understand how the services work. It's never as easy as you would think. You will always underestimate the amount of time you need to create these things. Unsurprisingly, the user experience for both services is not as great as the alternatives. You don't get like a nice single pane of glass for all your pipelines with expandable sections that you can quickly go into and go out of. CodePipeline's overview for the execution is pretty good overview, but it doesn't show you like multiple workflows very well. If you want to drill down deeper, you end up clicking across the code build, and then the user experience is just a big log. There can also be a performance problem, I'd say. So if you've got multiple code pipeline stages, because you're trying to break it up into lots of distinct steps, the transition step between each one can be a little bit slow. Now, they did improve the performance of this, but you still use S3 as an intermediate storage between your stages. So there's always a push to S3 at the end of a stage and a pull from S3 at the end at the next stage. And if you've got, a substantial amount of data, source code being passed around, which is quite common these days, that can really slow down your execution. So that's a bit of a problem, right? Because build and deployment speed is important. It is really important for developer productivity, I would say. And we should always be trying to get that deployment time down as low as possible. I have seen people overcome that problem by like just getting rid of CodePipeline altogether and just using CodeBuild. But the problem there is that when you're just using CodeBuild, you lose that structured workflow. Everything is running one job. You do have distinct phases, but you don't get any visualization of that really. It's just, they're all just steps that are logged out to a log file. The last kind of disadvantage I'd say is that source providers, be it from GitHub or elsewhere, are quite clunky to set up with CodeBuild and CodePipeline. Setting up authentication, there's different ways of doing it in CodeBuild and CodePipeline. They also have a reasonably new thing called connections, which is a little bit better, but you still can't have triggers in CodePipeline from multiple branches. Everything else out there allows you to specify like a glob pattern for your branches to trigger from PRs. CodeBuild allows you to do that, but CodePipeline does not. People end up then using a CodeBuild job at the start, which uses a wildcard pattern on your branches, and then this triggers the CodePipeline, and it's just not as seamless as you would want. It seems like we've talked a lot about the shortcomings now of them. How does the alternative compare? Do you want to go through what GitHub Actions is like in comparison?
Yeah, let's talk specifically about GitHub Actions, because it seems to be kind of the main contender in the market, even outside AWS, just because even in open source, everyone is hosting projects, or almost everyone at least is hosting projects on GitHub, and everyone is starting to take more and more advantage of the built-in GitHub Actions to do all the automations around their open source projects. So it kind of makes sense to also use all that knowledge to try to deploy applications in all sorts of different environments, including AWS. And the experience is actually fairly simple, in my opinion. I've been using this extensively for open source, not as much with AWS, but for open source, I have a very good grasp on what is the process to kind of create a workflow and make it run. And it always starts with a YAML file that is generally created in the root folder of your repository. Actually, it's not in the root folder. There is a special folder called .github. And in that folder, you can create another subfolder called workflows. And then every YAML file that you define in there is kind of automatically becomes a pipeline or a workflow, if you wish, that will be executed depending on the condition that you specify inside of your YAML file. So this is kind of what makes that integration almost seamless, because you don't really have to go and call APIs or click around the UI to enable a specific workflow. You just create a file, and as long as that file exists and is well formatted, your workflow exists and will be executed according to what you specified inside the file. In terms of AWS, of course, there is a step to integrate the two systems together. So GitHub needs to be aware of a particular role that needs to be assumed in order to have permissions to do all sorts of different actions. And this is something that can be done using OIDC provider. And used to be a little bit more cumbersome in the past, but I think now is a little bit more simplified. So maybe we can go in details in another dedicated episode. But yeah, basically you create an OIDC provider for GitHub Actions, and at that point GitHub Actions is able to assume a role and all the permissions related to that role. So in terms of why is this better? We already mentioned that it looks a little bit easier to define our workflow and make it run, because it's just creating a YAML file with a quite simple syntax. But there are a lot more advantages. And first of all, that is already, like if you're already using a GitHub as a source, your repositories are in GitHub, that's literally it. Like you don't need to create another source or another connection, or you just create files in the same repository and that's it. So that integration is very seamless. The other thing is that it's very easy to have conditionals. For instance, if a particular step is something that maybe you want to run only in the main branch, or maybe you want to run if that commit was a tag, you can have all sorts of conditions. Actually, the language is very flexible. That is very, very easy to do. There is literally an if attribute in the YAML statements, and that if attribute has its own expression language, and it is quite simple, but at the same time powerful enough for most use cases. And another thing that I really like that is also very simple, maybe in comparison with CodeBuild and CodePipeline, is the matrix feature. So for instance, a common use case, this is more maybe when you are building a library, you might want to run the unit tests against different versions of your runtime. Let's say it's a Node.js project, probably you want to run the tests against, I don't know, Node 14, Node 16, Node 18, just to make sure that people using different versions of Node.js can use that particular library without problems. This is extremely easy to do with GitHub Actions because you literally have to define a property that says, I have these 3 attributes that are variations of my pipeline, and the attributes will be Node 16, 18, and maybe 14. And then you can use these variables inside your action. For instance, you're probably going to have a setup step that says configure the version of Node.js and use that variable. And at that point, GitHub action is going to take all the variations that you specify for every type of attribute. For instance, Node.js versions, you might have also operative system. It's going to do a matrix with all of them, and basically it's going to execute all the variations for you. And the UI is actually very slick in making you see all the different variations that are running. By default, they are executed in parallel. So the amount of configuration is very minimal, and the result is quite powerful. The other thing that is very nice is this idea of third-party actions. That is basically, for most cases, you might want to do something that is very common. For instance, set up Node.js or authenticate against AWS. Like in other CI systems, you need to write your own bash script using specific CLI utilities to do certain things. And that's always either a copy paste, which is a little bit annoying, or something that you need to figure out every single time. And then you end up copy pasting from your previous repository. Using GitHub third-party actions, basically what you do is like you are importing a module, and then you say, do this thing and use this particular configuration. For instance, the action called setup Node.js is either you say reuse this third-party action, which is provided by GitHub itself, and say you only need to specify the version of Node.js that you want. There are, of course, other parameters, but it's literally import this module, initialize it with this configuration. I don't want to know exactly what's happening behind the scene, but I know that it's going to solve this particular use case. That might also be a little bit of a problem because you might start to think, oh, what about supply chain attacks? What if I'm using an action that maybe is not trustworthy and people can use that as an attack vector? This is definitely a concern, of course. But the good news is that GitHub has 50 official actions that they maintain themselves. And these are the most commonly used ones. For instance, setup Node, setup Java, all the basic building blocks that you might find on all sorts of different programming languages and runtimes. But they also do this thing called verified by GitHub, where the most commonly used actions, they actually audit them to a certain extent. I'm not really sure to what degree, but they will tell you, we kind of spend some time and this is trustworthy. So if you see that badge, you might be a little bit more confident that it's not going to create security problems for you. I still recommend you verify the source code because all these actions are actually open source. So it's actually another repository on GitHub, so you can literally read all the code. They generally run as containers. So what happens is that they will pull the code from that repository and run it as part of your workflow. So you can literally see exactly what's going to happen. And you can also tag specific commits on that repository if you really want to be sure you are running a specific version that you have been auditing. So this is just as a suggestion if you want to be really cautious about importing third-party source code into your pipelines. What else? I think, there is another interesting point regarding self-hosted runners. So in general, when you use GitHub Actions, the pipeline is running on GitHub infrastructure. And of course, that comes with a cost that maybe we'll detail a little bit later. But you can, if you don't want to run your code, your pipelines in GitHub self-hosted, in GitHub runners, you can self-host the runners yourself. And there is like an agent that you can install in anywhere where you want to run your code. It might even be, I don't know, a Raspberry Pi connected to the internet if you really want to. And at that point, you just need to register the workers with a particular project, and GitHub will dispatch the workload to this managed runners that you manage yourself. I think that's all we have. So maybe in terms of disadvantages, let's see what we can say in comparison with CodePipeline, of course. We said that there are a lot of things that are simplified because just the user experience of GitHub Actions is different from what you get with CodePipeline. But at the same time, you need to do this additional step of making sure that credentials are actually set up correctly and that you configure this OIDC provider to allow GitHub Actions to authenticate against your AWS accounts. if you use multiple environments, that comes with a cost. So also that's something to keep in mind. Some people complain that it is not the most reliable service. It has been going down a few times, and even if you use your own workers, that if the, let's call it the data plane, I don't know if it's the most correct terminology, but the orchestration plane, whatever we want to call it, if that one goes down, your workers on your own infrastructure are not getting triggered anyway. So that's also another case where you are not 100% in control. And also self-hosted runners, they have some quirks. I heard people complaining about they are also not reliable in different ways, and they seem to be a little bit different from what you get in the hosted, the managed GitHub runners, in a sense that there are some subtle differences in behaviors, and it's not obvious when they appear. So your mileage might vary, but be careful if you use the self-hosted runners. Make sure you test them, because it might not be 100% the same experience you get with the GitHub runners.
Yeah, it's probably a good idea, I suppose, just to try and use the managed runners where possible, unless for some compliance reason you need to keep that build running on premise.
Then we can also talk very quickly about pricing. If you're doing an open source project, this is actually the best part. It's totally free. Like if you're building a library and this library is your repository is public, you can build as much as you want, and it's literally free. So this is actually really nice, because it gives you an opportunity to experiment with GitHub Actions without having to worry too much. And it's funny that you can even do like scheduled executions. For instance, for the AWS Bytes website, what we do is every Friday at midnight, if we have a new episode coming that will be released that day, the website automatically builds itself and it will show the new episode. And this is something that we do entirely for free, because the whole website is open source in a public repository. So GitHub gives us all that service for free. So that can be very nice in different ways. But of course, if you are building a startup, you are not going to publish probably all your source code publicly, right? So what happens when you need something private, something more enterprisey? The pricing is really interesting, because on GitHub it's like you have a bunch of different services like repositories, GitHub Actions, I think maybe even Copilot now is part of all the different services that they offer, and you don't buy them like individually. It's kind of a one plan where you pay seats for developers and you get access to a certain amount of features for all these services. And in the case of GitHub Actions, you get 3,000 minutes per month, I think per seat, and that seat is $45 per year. So my understanding is that if you need more than 3,000 minutes of build time, this is of course using their own workers, the GitHub workers, you probably have to buy more seats. So buying more seats will give access to more developers, but also is going to give you more build minutes.
Yeah, I'm not sure I'm a big fan of that, just because why is the number of builds going to be tied to the number of developers? It seems a little bit like those things aren't necessarily going to scale linearly. I mean, I would joke like everybody knows every time you add a member to a team, your productivity goes down anyway, because you have so much more coordination to do. So maybe it should be the opposite. Anyway, I digress.
Yeah, on one side, I appreciate that they're trying to keep it simple, and you don't have to worry about too many dimensions and how they can affect your pricing. But at the same time, it's probably true that you might have specific use cases where, I don't know, maybe you end up paying so many seats just because you need more build time, but you don't really have as many developers, right? So, yeah, there are kind of implicit dimensions, and I guess if you happen to be in the standard use case, you're probably fine. But if you deviate from that standard use case, I don't know, maybe your pricing is not going to make that much sense anymore. And then what else can we say? There is a thing called GitHub Enterprise that is $231 a year. I think this is per organization, right? Not per user.
It's also per user per year.
Okay, and that one gives you environment protection, which I'm not really sure what that is.
Yeah. So that means if you want to have, rules, conditions that specify under what conditions can you deploy to production, so you don't allow everybody to create a build that can trigger release to production, those kind of conditions, then you need GitHub Enterprise for that, which is, it's something that I guess a lot of people might want, and it's kind of unusual that you would need to go from $44 a year to $231 a year just to get that. So I get your mileage is going to vary. Like pricing could work out really well for you with GitHub, but it could also get expensive if you've got long running builds with small startup.
So in comparison to all of that, how does CodePipeline and CodeBuild work? What is the pricing there?
I think it's a little bit, I guess, just more linear in terms of the number of pipelines and build jobs you have. So CodePipeline is one of the simplest AWS pricing sheets out there. It's $1 per month per pipeline, and that's it, whether it runs or not. You get one free on the free tier. On CodeBuild, then it depends on the instance size, so you can configure different instance sizes. The kind of standard one is general one, medium. That's $0.01 a minute, $0.01 per minute for Linux. You can also do Windows builds, they're more expensive. You can go down as far as the smallest ARM instance, which is like $0.0001 per minute. And if you want a really massive GPU on its own, it's like 65 cents per minute. So but it's just based on the number of minutes you execute. And there are some quotas, but you can get the quotas increased. So I would say that it's one of the advantages of CodeBuild is actually it scales pretty well. I have had cases especially on new accounts, where CodeBuild jobs can sometimes take a while to provision. And I guess this is something that will kind of come up now and again as AWS add more and more infrastructure and as more people run CodeBuild jobs. But I have found that sometimes, even recently, that you can end up waiting for a provisioning step. So that's something to be mindful of.
Yeah, I was about to say that this is another kind of trade-off, that with GitHub Actions, if you use the managed runners, you don't really know on what kind of hardware you are running your code. So if you need specific things like a GPU, because, I don't know, you're doing training models, whatever, you're not necessarily going to get a fine-tuned experience there. But if you either host yourself the runners, then you can use whatever hardware you want. But in CodeBuild, that's a lot more kind of obvious that you're going to pay for the compute you actually use, but at the same time, you can customize that compute as much as you want.
Yeah, that's a good point. Maybe it's a good point to talk about when to choose one over the other in summary. So I think maybe people have already made up their own mind based on what we discussed in the pros and cons. I'd say use CodeBuild, and CodePipeline if you have a good understanding of those services already and want this AWS service integrations. Also, maybe if you're all in on CDK actually has something called CDK pipelines, which allows you to create all these things very simply for you with a self-updating pipeline. We'll link in the show notes to a CDK workshop, which is really good. It talks about how you do that. But in general, I'd say if you should use GitHub Actions if you want to reduce the amount of time developers spend on maintaining the pipelines, because it's just a lower barrier to entry and not so steep a learning curve. And if you don't need those specific AWS integrations CodePipeline offers, I would see that more and more people are going to choose GitHub Actions to do this in the future. So it will become the well-traveled path. And CodePipeline, CodeBuild, maybe, it's still very widely used because it's just part of all the AWS services, and it's reasonably well documented in terms of third-party community resources, but it will not be. It's not the juggernaut that GitHub is. So you just won't find the same level of support. After that, we're interested in everyone else's opinion. Also, there's plenty of other third-party services out there. Circle CI I've used in the past as well, which has also been really easy to set up and comparable, I think, to GitHub Actions in a lot of ways. In terms of resources, if people are looking for other places to go, one of the reasons why we were inspired to talk about this topic today is because Paul Swale released a really good article a couple of weeks ago called Why I Switched from AWS CodePipeline to GitHub Actions. It's a really excellent article and well worth a read. We've also linked to a tutorial showing how you can set up authentication between GitHub Actions and building and deploying a web app to EC2. We'll also link to our previous episode, which is on the same theme, when to use other alternatives to AWS services. So please check out that last episode if you haven't heard it already. So thanks for listening, and we'll see you next time.